Hyperdimensional pens.
Okay, degree. Degree of a function. What does it mean? What is the? How do you find the degree of a function? Or what is the degree of a function?
Use the
Like in the angle degree?
Oh, it's the highest exponent.
Good job.
Oh.
Good job. It is the value of the largest exponent.
So you mean like x squared plus x plus
Yes, the degree would be 2. X cubed, blah, 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 yeah. All right, so value of the largest exponent.
I wish I put that second in, so it just says like exponent. Exponent.
Okay, so do you guys remember, let's see if I can find any of this type of stuff from last year? High, low, low, high, cross, bounce. Do you guys remember all that stuff?
I loved when we did that.
Yes?
Wait,
I was
is that for
taking
math
physics
too?
at the same time, so it was pretty easy.
Good,
Good.
good.
Frequencies.
Albertson, did she print the right form?
Yes.
Yeah, all right. Thank you.
Lord.
Okay. All right, so I'm going to show you some examples really quick of degree. Finding the degree. F of x equals 3x minus 6x squared minus 4x cubed plus x to the 8th. All right.
Hey, can you just pull up the one bit?
No, I am. I'm
So
waiting.
behind. I'm experiencing lag on my end. Yeah, I'm getting a bunch of lag here. Host migration.
Migrating hosts.
Okay. Now, if a kid says the degree is 1 because that's the first exponent, is that correct?
No, that kid, little Jimmy.
The degree is 6 because that's the largest coefficient. Is that correct?
No, little
Okay.
Jimmy.
So the degree is 1?
The degree is 8.
Oh, okay. Well, you said 6 because, and then you said it was.
I was giving a bunch of wrong answers purposely. So the degree is 8. All right, next one. Y equals x squared plus 3x plus 18.
Hold on, I got a quick question.
Yes,
So you just asked for the degree and that's it?
that's it. That's all I'm asking for
Okay,
right
but
now.
if you weren't asking for the degree, what would you do with that?
We're going to talk about what the graph, remember those pictures I just showed you? Today's assignment's going to ask you, what's the end behavior? Like this would be a low, high. This would be a high, high. You're not graphing today, you're just writing those things down, low, low. So those are the kind of questions I'm going to eventually be asking you. And then eventually we'll be graphing them. No. Okay, next one, what is the degree? All right, third one, g of x equals the quantity of x plus 6 times the quantity of x minus 5 times the quantity of x plus 2. I'm going to cover this one. Good. If I were to FOIL that double distribution, what would the degree be? 2. And if I took that x squared and distributed to this, the final degree would be what? 3. Do you guys agree?
I agree that the degree is 3.
All right. Really quick. Power 1, 1, 1. If you add up the exponents, does it equal 3?
Yes.
Okay. So with that being said, what would I have with this? Y equals the quantity of x plus 2 squared times the quantity of x minus 1 to the 7th. Think about what we did here with 1 plus 1 plus 1. What would it be here? 9. Now, do you have to multiply it all out to know the degree is 9? No. But I do want to talk about where kids mess up. Are you ready? They handle these fairly well. 7 plus 2, 9. 1 plus 1 plus 1 is 3. But then when they get to stuff like this, they say, oh, 8 plus 3 plus 2 plus 1.
Wait, what?
Up here, they start to add these exponents. Can anybody tell me how you know when to add and when to just take the larger?
Got them right.
Yes.
The differences between multiplying where you have like one term, or when you have multiple terms when you're adding a term?
Good. So this is multiple terms. We would call this expanded form or factored form. Same with this one. If it's expanded form, do you do any adding of the exponents? No, just the largest, you're done. If it's in factored form, is that when you add the exponents? Yes. Do you see the difference? Yes? All right. Questions? All right, we're going to talk about end behavior. How do you know if it's high, low, high type stuff? Part A, we're going to talk about when the degree is odd. What to do when the degree...
It's a little smear.
I know.
That's all.
Is odd. Okay, now we all know an odd degree function. I'm going to put a little thinking bubble here. This is the one that I like to think of. Like, I don't have them all memorized. I just think of particular functions. And I put two of them combined. Y equals x cubed. Is that an odd degree?
Sure.
Do we all know what the cubic function looks like?
No.
No?
I can't remember.
No one?
That's the whooshy one.
The whooshy one?
Oh,
This
I
one
thought
here?
I thought there was like the form, like it's
Yes,
yeah, I know what the whooshy one is.
Odd
It's the
because
best one.
because the 3.
And 3 is odd
It would be an even.
it was 9.
because
Odd.
2 whole numbers cannot be taken out.
Uh-huh. So if it's an odd exponent, x to the 3rd, x to the 5th, x to the 9th, they're not all going to look like this. Well, they will until you start adding
It's a
things.
tangent graph.
What is y equals x to the 1?
That's a linear graph.
Wait, so is a tangent a cubic function?
Okay. And it still holds the same properties as this that we're going to do right now. All right, this is a cubic graph. This would be x to the 3rd, this would be x to the 5th, x to the 9th, and so forth. Now, once you start throwing extra pieces in there, like x cubed minus 16x, is when you get those bumps in your graph. All right, but if it was just x cubed by itself or just x to the 5th by itself, it would look like this. What's the end behavior? It starts low and ends high. That will be true for all odd degree polynomials. Now, there's a piece of information I left out, and I'm going to put it in right now. That's not always true because it could go the other way. What determines whether it's like this or flipped around like so? What is it? The negative. So this one here would be a leading coefficient is what? Is positive. Do you guys agree if the leading coefficient is positive, it's going to start low and end high? And again, you don't have to like have everything memorized as long as you know what to relate it to. Relate it to the cubic graph. What does it look like? Oh yeah, it's low, high. All right. Now, what could change? The leading coefficient could be what?
Negative.
Leading
0.
coefficient, no.
Oh, no, that's not a thing.
Is negative. Right. If it's negative, think of y equals x cubed or negative x cubed. And what does the negative coefficient do to your x cubed graph? I heard somebody whisper it. It flips it? All right, so across the x-axis, so it looks like this. All right, so does that also start low, ends high? No. It starts what? Starts high, ends low.
It's settings.
Okay. So I'm going to look really quick at the one I showed you earlier. Looking right here, what is the degree of this function, x cubed minus 16x? 3. And is the leading coefficient positive or negative? So it should start low and end high. Is that what it does? Yes, all the bumpy stuff in between, we'll figure that out later. All right. Questions? All right, part B is what? The degree is even. Degree is even. What function should you be thinking of for an even degree function? Something you've been working with since the U shape, since Math 2. So what is that? Y equals x squared? Positive. Yes. And I need to put here, if it's y equals x squared, what's my leading coefficient?
Oh, baby.
Leading coefficient is
Degree is even.
positive. All right, so what happens with this parabola if it's positive x squared? Opens up or opens down? Up. So what would I say about the end behavior? It starts what? Good job. Starts high and ends high. All right, and what's the last one? It's still, the degree is still even, but the leading coefficient is what? Leading coefficient is negative. So what function do we think of? Y equals negative x squared. And if I have a negative x squared, what does that do to my parabola?
Turns it upside down.
Turns it upside down like this.
Turn that smile upside down.
All right. And what does that mean about my end behavior? It starts
And ends low.
low and ends low. All right. Now, again, I often have kids like memorizing each and every one. I'm not one to memorize if I can make it stick with something else, so I just stick it with these. Cubic is either high, low, or low, high, and parabolas are either high, high, or low, low. And I know what they look like, so I can figure it out from there. Got it? Okay, questions? All right. So, Tyron asked earlier, what other kind of question are they going to ask? That's what we're going to see now, the whole thing put together. So, examples. Without graphing,
So is this like number 1 or is this just like?
this is like the last section in your homework. The first few will just be what's the degree, or match it with the possible graph. Without graphing, describe the left side comma right side behavior. Without graphing, describe the left side, right side behavior. I'm going to put in parentheses and the behavior. So from now on, when I say end behavior, you know I'm talking about the start and the end, meaning the high, low, low, high stuff. Got it?
I wish this unit could all be like this.
Number 1, y equals 7 minus 3x squared minus 14x cubed all over 5.
Wait. So. Okay.
What determines whether it's high, low, low, high, high, high?
Odd or even degree.
odd or even, and what determines like if it's high, high, or low, low, or negative or positive. So those are the two things we need to figure out: degree, whether it's even or odd, and then whether it's positive or negative. What is the degree of this function? The degree is 3, which is odd. So we know it's going to be either high, low, or low, high. All right, before I go any further, I will tell you this. When you're doing today's assignments, I need you writing this down. Don't just say high, high, or low, low. You write the problem down and you write this. Degree is 3. Now, my leading coefficient. Is 7 my leading coefficient? It's not in the proper form. No. This is my leading coefficient because it has the, wherever your degree is, that coefficient's your leading coefficient. So is it positive or negative?
Negative.
All right, so be careful with that. Your leading coefficient's always going to be with wherever your highest exponent is, unless it's in factored form. All right, so think you can look back in your notes, but picture the graph. This would be the negative cubic function. Where does it start and where does it end? High, low. And I was just going to say that. Thank you. I was going to say, I know my kids last year asked that, they said that in Math 2 they wrote it like this. Yes? And if that's the way you wrote it, go for it. There's nothing wrong with that. All right. Number 2. F of x equals 11 minus x to the 4th. I'm going to let you try that one on your own. F of x equals 11 minus x to the 4th. Remember when you're doing homework, this is exactly what it should look like. The original problem, degree, positive or negative, and then your arrows or words, depending on how you're doing it.
So is it homework in the book or is it like in the worksheet?
It's a book. What's the degree? So that's even. So it's either going to be high, high, or low, low. Leading coefficient is the positive 11 or the negative 1. So it is negative. So it's what? Low, low. And again, if you use your arrows, that is perfectly fine. Number 3.
Is this the last one?
No. 2/5, and there's more, but I haven't written it yet. Before I write it,
Yeah, I'm thinking about my plan.
before I write the rest, I forgot to ask up here, does the 5 change the degree at all?
No.
Does it change the positive negative? What if this was -5? Would it change the positive negative?
Because they canceled.
It would be,
Positive.
it would become positive, so then that would have been positive instead of negative. Do you see
So
that?
how do we know which one to change? Negative 3x or the
Well,
negative
the negative says different.
The negative would change everything. It would never change the exponents.
Of course
But
not,
it's going to
like, say
change
there's a
negative
negative
7
5 in the
plus
bottom.
3
Sparkly.
plus 14. It would change them all.
Alright.
All right. So 2/5 parentheses t to the 3rd plus t squared plus 1. Is that 2/5 going to change my degree? It is not. Yes. Hustle. And we're going to talk about this one, so you may want to just hold off a second. The 2/5 does not change the degree. Because the 2/5 is positive, is it going to change the leading coefficient? No. Now, is this factored form where I add the exponents? And please don't be confused with the 2/5 in the front.
No, it isn't.
No. Because if I cover that 2/5, is that in their factored form?
No.
No, it's expanded. Yes, the GCF has been taken out, but it's still expanded form. Do you see that? So, is the degree 3 or 5? 3. Don't add unless you see multiple parentheses. The degree is 3. And leading coefficient is what? Positive. All right, so do your arrows or your words. So that's a cubic graph. Think of a cubic graph, and it's positive. So what is it?
Low.
Low, high. However you do it, arrows or words, it's up to you. All right, questions? Okay, number 4. Sketch the graph. sketch the graph, x to the n, and each specified transformation. Sketch the graph x to the n and each specified transformation. We're just about done. All right, the x to the n graph for this one is going to be y equals x to the 7th power. All right, is that a degree of odd or even? So we compare it to the parabola or the cubic graph? Cubic. And I will tell you this, if it is just x to the 7th or x to the 5th or x to the 9th, it's going to look like a cubic graph, exactly. The only thing is, the larger the exponent, the quicker your graph increases. Same is true with the parabola. So if that was x to the 2nd, we know it would look like a parabola.
Yeah.
What about x to the 4th?
Be like this.
It's just a thinner parabola. X to the 10th?
X to the 1 million is just infinitely high.
Still a parabola. What makes all the bumps and bounces and stuff? It's when you throw extra stuff in there. You see how it's no longer just x to the 6th power or x to the 4th power. Do you see that? Once you throw extra things in there is when it has all the bumps in your graph. But if it's just x to the n, it's going to either look like a parabola or a cubic graph. Which one is this going to look like? Cubic graph.
Interesting. How much stronger the pen springs than the
Okay. You see it? Letter A, y equals parentheses x plus 3 close parentheses 7th power. Gentlemen, paying attention. All right, you know enough about shifting from first semester and from last year. Inside, is that an up-down shift or a right-left shift? Right-left. And because it's plus 3, it's going to shift which way? Left. How far? Left 3. And because the A is still 1, the coefficient is still 1, it's not getting any thinner or wider. It's staying the same. Okay. Questions? Part B. Y equals negative parentheses x minus 2 close parentheses 7th power, and then a plus 3. There are multiple things going on this one. Anybody tell me, what does this minus 2 in the parentheses do? Right 2 and the plus 3 on the outside?
The negative or no?
No, but it does do something. What does a plus 3 on the outside do? So right 2 up 3? Yes. And what does this negative do?
Makes the thing negative.
Upside down, flips it around. All right, so right 2 up 3, and then it flips it around the other way. Questions? Doable? All right, I don't have your assignment sheets ready for you today, so we're going to write it down for now. Page 109, 5, 6,
Oh, you don't have your...
yeah, 9 through 16, and 29 through 36.
So much work.
Questions?
You too.